First, before we start doing probability theory, like the real stuff, we have to make sure that you guys understand. We have to make sure that you guys understand how to count, okay? Not just like that, but if you have all these different options, different possibilities, how to quickly find out the total number of options or possibilities, okay? And so to get and illustrate an example, let's start with example 1. So let's suppose you have two pair of jeans, one blue and one black, and then 3 t-shirts. How many choices of these outfits do you have? Assuming that you are only wearing one pair of jeans and one t-shirt, not all 3 at the same time, okay? So to do a tree diagram, you can kind of start by saying, all right, so we have one pair of blue jeans, one pair of black, and then let's say I pick blue. Well, if I pick blue, then I have to pick a shirt. How many shirts can I pick? So we have a white t-shirt, a yellow t-shirt, and red. And then, of course, if we decide to pick black pants, it's the same story. White, yellow, and red. Does that make sense so far? Okay. How many outfits is this? 6. Okay, you just follow all the way to the end. You got 1, 2, 3, 4, 5, 6 final outfits that you can make. Make sense? Okay. Example 1b, very similar. Go ahead and try that real quick using a tree diagram. I know this is going to get really easy really fast, but we do want to be able to draw these tree diagrams out. Okay. Yes. So how many are we getting?
12.
Okay.
It takes too long.
It does, and we're not going to do that every time, but you should be able, one of the skills to in this unit is to draw a tree diagram for simple problems to illustrate why the answer is what it is. But yeah, you can do like C1, C2, C3, and then each of those have 1, 2, 3, 4 options, right? So you could just count that there's 12 there, okay? Which leads us to this. So the fundamental counting principle tells us that if we have 2 different groups of items, if I'm picking one item from each group, that you can just multiply the number from each, the number total from each group to get the total number of options. Does that make sense? You should all be going yes, right? Okay. Otherwise, if you give me blank looks, it looks like you weren't paying attention, and this is, to me, this is like very easy. I hope it is. Do you guys see the shortcut here, right? 2, 3, what do we get? 6, 3 times 4, 12, pretty basic. Okay? Why don't you guys do 2A and 2B? Should take you about 30 seconds. All right, Matthew, what are you getting for 2A?
2A got 150.
How'd you get that?
I Multiply 10 with 15.
Pretty straightforward, right? Okay. Jackie, what about 2b? Thanks, Jackie. How'd you get that? Okay. Questions? Let's turn the page. We're going to not do the tree diagram. I think if we're starting to understand, what if we have more items? 2 pairs of pants, 2 belts, 3 t-shirts. 2 times 2 times 3, 12 outfits. Pretty basic, right? I know it's kind of silly to keep doing this, but the counting gets more involved, okay? Why don't you guys try the rest of the page, take a minute, and then we'll go over these, and then we'll answer the lotto question. And while you do that, I should look up, I forget what the rules are, like how many numbers. So I'll find that out real quick. All right, Jared, 3B. How'd you get that?
I did, 3 courses and 8 sections for each course. So it's like 8 times 3 plus 5 times 2 plus 4 times 6. Right?
Michael, how did you?
Meow.
I did 3 times 8 times 5 times 4. 3 courses, 8 sections, 5 English.
Oh boy, Brian.
8 times 5 times 4 times
8.
times 5 times
That's it. Just because there's a 3 in the problem does not mean you just randomly multiply all the numbers that are in the problem.
I got the right answer.
8 times 5 times 4, you did. That was a very roundabout way of getting there. But so 160 schedules, okay? All right. 3C. Let's go over to this group. Jonathan, what did you do?
Multiply by 2, 3, and 5.
And what'd you get?
30.
Sounds good. So 30 different pizzas. Okay. And let me go through these 2 with you guys. Hopefully you had a chance to try them, but these are a little trickier. Okay. If your answer for number 1 was 40, that's not right. Okay. Again, just because you see a 4 and a 10 in there doesn't mean you multiply them, right? You got to actually think about what's happening. So think about if you have question number 1, question number 2, question number 3, and so on, all the way up to 4, 5, 6, 7, 8, 9, 10, right? How many choices do we have for question number 1?
Does that mean there's 3 for 2?
Can you pick A more than once on a test?
Oh, yeah.
So what should this one be?
4, 4, 4, 4.
So in other words, what we really want to do is not 4 times 10, but 4 to the power of 10. Does that make sense? What is that? I don't have a calculator. Somebody help me out.
That's about like
1 million.
this guy.
Nope. I don't think it's 1 million.
$1,048,576. Like that. Okay.
1,048,500.
Wonderful. All right, let's go through the telephone example. So we have 3-digit area codes, right? It's your area code. Then you got 3 more digits, followed by 4, right? It says area codes and local telephone numbers cannot begin with 0 or 1, meaning right here at the beginning, the area code does not allow us to have 0 or 1, and then the same thing for that first number of the phone number. Does that make sense? Okay. So that leaves us how many numbers as a choice for the first digit?
7.
8. There are 10 digits that you could possibly have, right? 0, 1, 2, 3, all the way to 9. And 0 and 1 are not allowed, so that's only 2 through 9, which is 8. I know 2 through 9 might seem like 7, but it's 8 actual numbers, right? How many digits could I have for the second one then?
10.
Are we allowed to repeat? Absolutely. Okay, and now here we're back to 8, but then 10 the rest of the way. So what is that going to be when we multiply that all out? And yeah, you could use powers here, make it a little shorter. So what are we getting? 640 million? Billion? How many zeros? 1, 2, 3, 4, 5, 6, 7. 8 zeros? I got 8.
Chieftain, I don't know about that. This is like this, see?
I got 10.
10 zeros?
What?
No,
I said 640 million.
How many 8s are there?
2.
So that's 8 squared, right? And how many 10s are there? 1, 2, 3, 4, 5, 6, 7, 8. So that's 10 to the 8th. And I'm getting 64 followed by 1, 2, 3, 4, 8 zeros. Okay?